Okay, so we are going to look at absolute value equations and absolute value inequalities. And there's a procedure for each one. Let's notice our first thing when we see absolute value equations, things like this, where there's absolute values within the equation, is to get the absolute value by itself on one side. And that's very important. So notice that that -4 right there is not in the absolute value. So we want to get it over to the right side of the equation. So the first thing I'm going to do is add 4. I'll add 4 to the left, and I'll add 4 to the right. So I'm going to get the absolute value of 2x plus 6 is equal to 6. Now I have the absolute value. This entire quantity that's in the absolute values is by itself on one side. So I am now going to solve two equations. In the first one, I just dropped the absolute value. So the first one we're going to solve is that. We just drop every symbol in there. Okay, and the second one, we're going to drop the absolute value, but we're going to make the right side of the equation negative. So the 6 that's over on this right side becomes negative. So notice one of them, it just stays positive and we drop the absolute value. The other one, we make the right side negative when we drop the absolute value. And let's go ahead now and solve these linear equations. So the first one, I'll just go over here, actually right there. I need to subtract 6 to start to get my x by itself. And that's going to give me 2x equals 0. 6 minus 6 will be 0. And then let's divide out our 2 that's still in front of x. But of course, 0 divided by 2 is still going to give us a solution of 0. And then this one, let's do the same thing. Let's subtract our 6 to get rid of it on the left side. Of course, we'll have to do that to the right as well. And that gives me 2, oops, hate it when it does that. 2, well, it's still going to do it. I get 2x equals negative 12 here. And now let's divide out our 2 to get x by itself. All right, and we will get x equals negative 6. Now, it is not necessary to check these, but you can if you want to. If you put 0 back into the absolute value, this will end up disappearing. We'll get absolute value of 6, which is 6 minus 4 equals 2. Or if we put the negative 6 in, we'll get negative 12 plus 6, or the absolute value of negative 6, which will be 6 minus 4 equals 2, and both will check. And just like we did with quadratics, we usually put these into set brackets as a list, and it doesn't matter if we put them in order or not. Now, let's take a look at what happens when we have an absolute value inequality. So just like with the absolute value equations, we have to make sure the absolute value is by itself on one side first. Then we have two different types of problems. If it's less than, if our symbol is pointed toward the left, then we are going to solve a double inequality where we put a new inequality on the left and the negative of whatever is on the right. And then if it's a greater than problem, we are going to solve two inequalities. The first one, we will drop the absolute value. And then the second one will drop the absolute value, change the direction of the inequality, and put a negative on the right side. So let's take a look at both of those. Let's notice this is a less than, so it's one of these. But first, we need the absolute value by itself on one side. We do, in fact, have that. All of this is by itself on the left side. So now let's go to solving a less than type problem. According to our less than directions, we're going to take this number that is here on the right and we're going to make it negative. And we're going to put in a new inequality. We're going to drop the absolute values. And then our 12 on the right stays the same. So notice, this number went to the left and became negative. We used the same inequality that we have right here. We dropped the absolute values and this part stayed the same. So we now have a double inequality. Let's solve it. Now let's remember when we were solving the double inequalities, we pretended like this left part didn't exist. So if we were just solving this right part, we would add 8 to get x by itself. So let's add 8 to all three pieces, plus 8, plus 8, and plus 8. Negative 12 plus 8 will be negative 4. We'll get 2x in the middle. And then 12 plus 8 on the right will be 20. Now we still need our x by itself, so we would divide by 2 to get x by itself, but let's do that to all three pieces. So I've divided each piece by 2, and now we will have, on the left, negative 4 divided by 2 is negative 2. In the middle, we'll just get x, and then 20 divided by 2 is 10. And there is our solution, and we would graph this just like we graph our normal double inequalities. All right, now, let's take a look at this greater than problem. First, let's notice the absolute value is by itself on the left, so we can go ahead and proceed with step 3. Since this is a greater than problem, we're going to solve two inequalities. So our first inequality, we just drop the absolute value, so it's that. Our second inequality, however, will drop the absolute value on the left. We will flip the inequality symbol, and we'll put a negative 12 on the right. All right, so let's solve both of these. So the first one, let's add 9 to get x by itself. Add it to both sides. So we'll get 3x is greater than 21. Let's divide our 3 out. It is not a negative, so we won't flip our sign. So we get x is greater than 7. All right, now let's do this one over here. All right, so again, let's add 9 to both sides of the inequality. We will get 3x is less than, oops, I hate it when it does that. 3x is less than negative 12 plus 9 will be negative 3. And just as we did with the previous one, let's divide by negative or by positive 3 to get rid of the 3 in front of our x. And this ends up being x is less than negative 1. All right, now if we had to graph this thing, let me just do my draw feature on here. This would actually end up going on a number line. And notice we have negative 1 and we have 7. So hopefully I made this big enough to put them all on there. And I apologize, I'm not going to mark all the numbers just because I can't draw well here. 2, 3, 4, 5, 6, and 7. So down here is 7 right there. So if we were to graph this thing, we need x greater than 7. And recall a greater than is going to be an open bracket or an open circle. And that's not a very good bracket, and we would shade going out this way. And then x less than negative 1, we'd have a going this way. And so if we were to write the solution in interval notation, we'd actually have two intervals from negative infinity to minus 1, and then from 7 to positive infinity. And we use a union symbol, looks kind of like a U, to say we've got both of these.